This time, we will try to combine a soft and technical talk. After all of that is needed when dealing with complicated refactoring, right? We've probably faced legacy code and the dread of refactoring it to fit modern ages. In this talk, Ivan will share some experiences of his own and what he sees as a good way of dealing with it. We will talk here about the past, the present, and the future, about common situations and code smells that lead to heavy tech debt, about organizing the team and the process during the refactoring. Finally, we throw some refactoring tips and best practices that help keep the project somewhat reasonably easy to maintain. Ivan Herak is now in front of us, senior web developer, team lead, and tech lead, often diving deep into legacy areas no one else wants to touch, especially dragons. He likes his code the same as his cars, 15 years old and barely working. Let's start, Ivan.
Hi, hello everyone. Welcome to this late night show where I will try to take you through time a bit. My name is Ivan. I've been working at NetGen for the past 10 years or so, and for about 4 of those years I've been working exclusively with legacy, with code that nobody else wanted to touch, that nobody else wanted to do anything with. So first I was just wondering, how many of you were at Ivo's lecture this morning at 10 a.m. about legacy? Okay, a decent amount. So you know, his talk was a little bit more philosophical. It was not, it was language agnostic. It had just some insight in how you think about legacy. I will try to do a little bit more technical talk where I will try to deliver some of the techniques on how to work with legacy code. So how many of you work or have worked with legacy? Obvious question, yeah. And how many of you who worked with legacy loved working with legacy? Okay, there are a couple. Congratulations, you're the brave ones. Yeah, this is similar to what we had a little vote about how many people love legacy, and around 65–70% of people said that they hate legacy, they don't like working with it. But legacy is all around us, right? So my question is, why is that? Why do people hate legacy code? I have theories that there are 2 points. One point is it is not sexy, and the other point is that they do not know how to approach it. The fact that it is not sexy, we can't do anything about, at least I can't do anything about it, but maybe we can try to figure out how to approach legacy code and make it easier to work with. So now let's go back to the past. If we are trying to approach something, we have to figure out what actually are we trying to approach, right? So what is the definition of legacy code? If you ask any developer, they will give you a different definition, like Eva said in the morning. It's code that is no longer supported. It's code that somebody else wrote. It's code without tests. It's code that's not testable, that's not documented. Code is, like Eva said, as soon as it hit production, it's legacy code. I'm going to be even stricter with this. My opinion is that code is legacy code as soon as you have left it untouched for 30 minutes. Now I'm going to give you explanation why. You write something, you go to lunch, and then you go back. That code is already legacy code, because now when you get back and you look at it, you again have to read through it, you have to get your head back into it, think about what are you trying to do, what are you trying to accomplish, and what all these parts there mean. That's the same process that you go through when you're approaching 5 years code. If the code is 5 or 3 years old, that process will take maybe half a day, maybe a day. If you go back from lunch, it will take 1 minute. But it is the same process, okay? So when Marty looked at this clock, tower clock, if you remember it, it was broken, right? And everybody saw just a broken clock. And nobody knew what's the story behind it. Nobody knows that that story had its purpose, that clock had its purpose. They had its timeline, that they were having problems, that they were having deadline, they were having different people messing with it. It's same with code. We just see broken code. We don't stop and think about it, what made this code the way it is. It never just appeared. I doubt there are many developers in the world who wake up in the morning and go, oh, I'm going to write shitty code today, right? Nobody does that. But circumstances happen, life happens, and then you end up with a shitty code, broken code. And then you have to refactor it and work with it. Ivo talked more about this in the morning, so I won't dwell much about it. So let's go back to the present. So now DeLorean is in the present. The code has been shipped to the production. It's live. There's beer. There's pizzas. Everybody's happy. And you can hear senior developers saying, oh, thanks God, I don't have to look at this shit anymore, right? So that's exactly what happens. The code gets passed on to someone junior, without supervision often. The code gets built, there are features added, years go, pass by, and it gets more and more complicated, it gets more and more, it accumulates technical debt, and now it's time to refactor, now it's time to upgrade. So you have in front of yourself one big ball of yarn, you have mess, you're looking at it, you're looking at the code, so what do? You start coding, right? No. That's a first big mistake you can make. You don't start working with code at all when you're trying to refactor a big project. First things you have to do is set up some baseline and some ground on which you can be stable before you start the refactoring process. You have to have communication set up. You have to have one source of truth. What does this mean? This means that you have to have a single person who is responsible to say, we will do this, or we will do that, or we will do that. So that's one thing that I find very important. And also set up some ground rules within the team. We as developers, we start programming so we don't have to talk to people, right? Not because we like talking to people. Unfortunately, in the real world, it doesn't work like that. If you want to be a really good developer, if you want to be a real senior developer, you have to get good in communication. You have to know how to talk with your clients. You have to know how to talk with your product owner, with your project manager, with your fellow developers, with developers who worked before on the project as well. So you have to set up communication channels between all these different actors before you start programming. You have to get as much information as possible. You have to have event storming and stuff like that. And during that, one of the ways to do that is 5 whys. 5 whys is technique from Toyota Production Service in 1970s. It means that you have to ask why 5 times to get to the bottom of the real issue. One stupid example is you start working on something on the upgrade, redesign, and the client says, oh, we want to have this button more visible. You ask why? Well, because we want more people to click on it. Okay, why? Because we want them to go to another page. Okay, why? Well, so they can give us an email address. There's a form with an email address. And you go, okay, why do you need customer's email address? And then they say, oh, we want to send them newsletters. And then you go, oh, nobody told us that you have a newsletter module, right? So you went from making a button visible to discovering they have the whole module that you didn't know about. Also, while talking to the clients and customers if possible, try to figure out what are the bugs that are addressed as features and what are features that are addressed as bugs. Both exist. We had an issue where a product owner was explaining one module to us how it works. We were like, okay, we get it. We can refactor this. And then during refactoring, we found out there was a bug. I mean, it was in plain sight. It was clearly a bug. So we fixed it. We pushed it to testing, and the client said, what the hell is going on? It doesn't work as it used to. They were like, yeah, of course it doesn't work as it used to. We fixed the bug. And they were like, no. You have to go back, and you have to fix that. At that point, it's probably wise to do like a timeout. Not go back to the code, but do a timeout, and just gather everyone around back, and ask them, what do they need with this module? This is probably the hardest part, because the client will always start talking about how they used it, how they used the existing one. You have to push that idea away from them and try to get them to say to you, to tell you what they really need. And then you will decide if you need to refactor it, replace it, or remove it. Those are the big 3 R's. You will need someone. Sometimes you will just need to upgrade the code. Sometimes you will need to replace it. For example, if you had legacy search in database and now you want to use Solr or something like that. And sometimes you can just remove it. And that's the best part. That's the part I like the most, removing code. Less code, less bugs. Okay, so now you have the communication set up, you have the team assembled, and yet it's not time for coding. First, it's time to set up some ground rules. Set up the way that pull requests and code reviews will be done. And of course, do code reviews. In our project, which was rather big, we had multiple teams working on it. We set up a rule that there had to be at least 2 approvals, and that both of those approvals had to be from different companies, different teams. That meant that the code, the new code produced, was a collective ownership, but also it was collective responsibility. Now, if something bad happened, something bad went into testing or production, it was never just one person's fault. It was always the fault of at least 3 people and multiple teams. That makes it easier for everyone to share responsibility and to know the code, to know different modules and how they work. Set up rules for commit messages. Chris Beam's famous Beam's rules, if you don't know them, read them. You don't have to use all of them, but use most of them. Probably you all have some kind of a ID issue tracker. Use issue tracker ID in your Git commit messages, in your branches, in your pull requests. It will make your life easier, and it will be easier to debug later on. I will once again say, write nice commit messages. Bad commit messages are pure evil. They are fine if you are working by yourself, okay. But if you're working with a team, you have to write meaningful commit messages because they, in the end, save a lot of time, really. Code styling. I'm not going to be pretty particular if you want to use tabs or spaces or Unix line endings or Windows line endings, you do you. But within the project, you have to do one of those. And don't enforce this on the level of pull requests. It doesn't make sense. So have some tools, proper tools, that will do that for you. PHPCS Fixer is a great tool. Use that. Have any of you used Captain Hook before? Yeah, just a couple. Look it up. We use it on most of our projects. It's a pretty cool tool. What it does is it enables you to set up Git hooks through Composer install. So once someone installs the project on their computer, they run Composer install, and they get Git hooks installed. That makes sure that everyone on your team will have the same Git hooks, pre-commit, post-commit, post-checkout, whatever. What's awesome is you can write actions in PHP. So you can write PHP actions that will be run on Git events, and you can check if the commit message has a task ID, if git commit is in proper format, if, I don't know, composer lock is committed, if composer JSON has been changed. You can run PHP stan, you can run tests, you can do whatever you want here. Okay, so now we finished setting up the project. We got the team up to speed. Everyone is on the same page. Now we can start. Now again, now we have this big pile of mess in front of us, and we don't know where to start, what to do first. My personal choice and what I suggest is try to delete that code. Why? Because that will make you read through the code. That's something that will make you familiar with all the places you have in the code, with all the different modules. It will make you understand the code a bit, and deleting that code shouldn't break anything, right? Use tools for that will help you. Use IDE, use Rector, use PHP stan that can use that as far as I know now, but don't rely on them completely. You never know if previous developer did something that doesn't comply to any PSR or anything, and the tool might not recognize it. So don't rely on it, but use it to help you. Next low-hanging fruit that I would suggest is get rid of the comments. Now, I don't mean to get rid of all comments. Just always the comments are supposed to just show why something works. They're not there to tell you what. If the comment is telling you what some code does, extract it to method. Because if we have this in the main method, It's just a clutter. It's just a mess. It has a higher cognition load, right? It's harder to understand. But if we do this and extract it to this method, now our main method, which is calling this, is cleaner. We can read it. It's in plain English, basically. And if you really have to comment something, comment why something has been done. Maybe you have some hack that you have done because a library has a bug or something like that. That's when comments are useful. And also, update your comments. Code never lies, comments sometimes do. You will find that quite often when you do like a git blame, git annotate, whatever you want to call it, you will see that the commit that introduced the comment was way older than the code. And it's probably not up to date, so be wary of that. Single point of entry, what does this mean? This means that we have two classes, and when we look at the calling graph, we see it goes like this, just like a ping pong. Just goes left and right, left and right. We want to get rid of that. Again, we want to lessen the cognitive load. I will talk about cognitive load a lot because for me, it's the main thing that you have to do if you are dealing with heavy refactoring, because first you have to understand the code to be able to refactor it. So if look here, we had like some discount service, and it has 3 methods that were always called in the same order. It was always like this. So it's now harder to refactor this sum service. So what do? Now we just wrap them all into one method. And now the discount service has 1 public method and 3 private methods. We reduced its public API. We reduced the part which we have to worry about. Now, when we have this, we just have to make sure this method works correctly, and we can change all of this. And also our main sum service handle now is cleaner to read. It's easier to refactor. I will not talk a lot about testing. There are a lot more smarter people than I am that have done workshops and talks and blog posts about unit testing. If you haven't checked Anna Filina, she has some great write-ups about unit testing legacy code and how to get it to be testable. But we do need some kind of testing, right? You are doing something. The biggest problem is usually you don't know what to test. You don't know what will be the input. You don't know what is the expected outcome. You are asking product owner, they don't have any idea. They just know about the happy path, right? They don't know all the edge cases. So I would suggest just running both of those things. You develop a new shiny implementation, and you have the old implementation, and run it in parallel. We did it something like that when we were refactoring the product import. We were getting some XMLs from third-party system, and we didn't know what kind of garbage could be in there, and we weren't sure what are the expected outcomes. So we just implemented new product import, and we ran both together, and just did a PHPD for something to show what are the differences. During that process, you can also write new tests, right? Now you get to cover your new code with new tests because you know what are the edge cases. Bonus points if you can run this in production, test in production. I know it sounds sinister, but it's not, I swear. For example, if you have an invoice generator, you can create a new implementation and legacy implementation, and you push both to production. And then you have a legacy implementation generating invoice and sending it to the client, just as it was before. But make the new implementation send the invoice to you. And so now you can run it in production and just compare if the invoices are correct. If you run this for, 2 months, and you're sure both implementations are correct, you just flip a switch, some feature flag or something, and you make new implementation sent to the client. And then you can just delete the old implementation. Strangler pattern or branch by abstraction. How many of you were on Paul's talk yesterday? Okay, not a lot, but yeah, there are some. Strangler pattern and branch by abstraction are pretty much similar, and to be honest, I started doing this before I even knew there's a name for that, that's a concept, and it will come pretty natural. The basic is this. This is the original. What do you have? And then you introduce some kind of proxy, some kind of a middleman, that will route the requests either to new shiny code or to legacy code. It will branch out the implementation. Naturally, over time, you will have more and more and more shiny code and less and less and less legacy code. And in the end, you will only have new shiny code and no legacy code. The difference between the strangler pattern and branch by abstraction is only in that in strangler pattern, you are doing this on a different system. So new shiny code in strangler pattern is on a completely new system. It can be a new language version, like Paul said, or whatever like that. And in branch by abstraction, you are doing this within your own code base. So Paul was talking about strangler pattern, and as a proxy, I believe he used Nginx. And I will talk about branch by abstraction. And as a proxy, we'll be using just abstract class. You will just one level up of abstraction in class. So let's do a little bit of example in PHP. So we have some legacy class, find products. We have a query, we have conditions, and we see it has a flag that says it will either return count of the products or the actual products. So we want to create a new shiny search service. First, we won't do much. We will just introduce new proxy search service. Proxy search service will have a legacy service injected. And in the beginning, we will just pass through. You do this, and you push it to production. So continuous development, continuous delivery. We don't have to worry about any new implementation yet. We just do this. This is just preparation. But now we want to implement new product search service in a proper namespace. And we inject that as well into proxy search service. So now we will have our proxy branch out the code either to the new service or to the legacy. At the beginning, we decided that we would just implement the count method because it's easier than actual search, for example, and we will just implement that. Is this count? Just send it there. Otherwise, business as usual. And after a while, you actually work on new search service to implement the find method, and you will have two different methods. You will have find, count. It will be clear interface with a clean implementation. At this point, you can either remove the product search service, but you can remove it only if you can also change the code that's calling it, right, the client code. If you're dependent on the interface, you can just leave the proxy search service as well there. Okay, so this was how you would approach refactoring and what are the best things how to start, how to do it. But I think that the best way to approach refactoring legacy code is to write code that's not hard to refactor. So yeah, you don't want some beef coming around in a DeLorean and trying to beat you up, you know. So let's see what we can do. We should write clean code. Clean code, this is a definition from David Scott from Beyond Legacy Code. If you haven't read this book and you're dealing with legacy code, I encourage you to read it, it's great. So many people talk about legacy code, about clean code. My colleague had one great definition about clean code. He said that it is as teenage sex. Everybody's talking about it. Everybody thinks everyone else is doing it, so they say they are doing it, and that in reality, nobody does it. So yeah, clean code, it needs to be cohesive, loosely coupled, encapsulated, assertive, and non-redundant. So let's go through all of those points and see what needs to be done. Cohesive code, it means that we write code that belongs together. We don't try to make our service or our implementation do everything at one place. We separate concerns, we do proper, smaller classes, smaller implementations. No God, do you know what God objects are? Objects where only God knows what's going on in there, right? This is one example of God object, you know, it has discount service which deals with calculating discounts, with validating voucher, with printing invoice, all kind of stuff that shouldn't be in this service, right? We should split this up in at least 3 different services, at least. Loosely coupled code, this means that you can change one implementation and the other code doesn't depend on it, right? So use interfaces for that. Favor composition over inheritance. Inheritance is great if you are all family and you have a clean lineage. If it's code, we prefer it to be a lot shorter than that. And yeah, try to implement it so it can be easily replaced. One example that I usually share with when I'm a mentor or something is quite simple. If you have some kind of a service, I name this campaign service, whatever, and you need to introduce a caching layer, right? First step is to write an interface for that method, for that service if you haven't already. I often hear people saying, oh, do we need interface for everything in our code? It's a userland code, it's our project, do we really need the interface? Probably not. But once you get to the point where you do need interface, just write it. You don't want to cram all the caching implementation into this service. Campaign service needs to do one thing. It needs to worry about campaigns. So it's the core implementation. If you need to write a caching layer, write it outside of that. So what you do, you just have this alias as core implementation, right? It's in core namespace. And then you create a new implementation, which will be cache campaign service. It will satisfy the same interface, and you will just make it alias of the cache. This is all the Symfony YAML service definition. I haven't updated it, but if anybody has any problem reading with that, please let me know. But I believe the pens injection is pretty clear. So this means that now we can switch out. Maybe on development we don't want to use caching at all. Okay, we'll just send it to core and we will have a concrete implementation. Maybe on staging you will use, I don't know, memcache, and on production you will use Redis caching. Again, it's quite simple to switch it out because the outer code just cares about the interface. It doesn't care about the actual implementation. So that's loosely coupled code. Encapsulated code, do everything so it's hidden. Write it like a black box. Do private by default, do final by default. I usually say that writing public methods is similar to having children. You will have to support it for the next 18 years. So don't do it. It's easier, it's a lot easier to open something that's been closed than to close something that's been opened to the public. Reduce the public API, hide as much information as you can, and treat it as a black box. So how do we get to this? There's a principle called outside-in programming. It means that once we have, for example, this payment, we know we need to write the payment system. We know that we will get some kind of payload from third party. We know we will have some kind of gateway that will process the data. And so what do? One option is to start writing gateway, because there's documentation that we can start with that. Outside-in programming says, okay, let's just start from the beginning, from what we know. So we just write, okay, this is basically pseudocode at this point. We write this without knowing how this method will work and without knowing how this method will work. We just know its interface with its public API. We know what are we going to give to that method and we know what we can get back. So this is why you write interfaces in the first place, because here you can have interface injected and you don't need to deal with how it's really implemented. So now we have this code. This doesn't have to worry about how gateway works or how payload looks like. We'll deal with that later on. So that's how you get really nice encapsulated black box code. Assertive code means that objects do not rely on other object state. It means that they are self-contained and self-preserving. They don't care about anything else other than themselves. One stupid example of that is this. We have printer, which is supposed to print document. But the printer has to know if the document is PDF, then we will use this to print it. If it's document, then we'll have to print it some other way. But that means that if we change the document and add some other type, we will have to change the printer itself. And we don't want that. We want the printer to just care about itself. One simple approach to this is just to have document, create some print view. And here we will have, if I am PDF, then I will do this. If I am the document, then I will do that. That means that the document will care about itself, and the printer will just print. Naturally, this is a simple example. If it's more convoluted, you'll have some factory or something to create print view, but the point is that other implementation doesn't have to know about something else, some other project. Non-redundant, non-redundant code. I think this do not repeat yourself is one of the most misunderstood concepts in programming. This doesn't mean you are not allowed to have duplicate lines in your code. If your code looks the same, but belongs in a different domains, it's perfectly reasonable and desirable even to leave it like that. If it doesn't care about the same stuff, it just looks the same, it's not the same. So it's always a lot better to just leave duplication as it is than to do some kind of a vague abstraction that is going to make your life hell easier later on down the line. So do not repeat yourself, do not repeat intent, not code. It's okay to repeat code if it's not about the same objects, if it's not about the same domain. Object calisthenics, again, this is from William Durand. You can read about it. There are a lot of rules. Again, you don't have to follow all the rules, but at least follow some. One level of indentation, most of it is about one level of indentation. And that's, again, just to lessen the cognitive load. It's a lot easier to read the code if it's in a straight line than if you have multiple level of indentations, if you have a nested for each, nested ifs, nested else, and stuff like that. Speaking of else, try not to have else keyword. How do you do that? Well, you can achieve that if you write small, practical methods in which you can practice early return. Handle specific cases early on. If something which we don't not want, return or throw exception. And then you don't have else keyword because you can return as soon as possible. Wrap primitives into value objects. I will talk about that a little bit more later on. Do not abbreviate. And yeah, tell, don't ask. Those are, for me, most important rules from this whole object calisthenics blog post. While at naming, namespacing. Use proper namespaces. I mean, this should be self-explanatory and completely reasonable, but again, this is a real-life example from the project that we worked on. We have formatter, which implements a formatter interface, and it has a method that does formatting. Does it sound like an entity? No, it does not. Why was it in entity namespace? That's beyond me. So yeah, don't do that. Set up proper domains. While we're at it, when you are discussing with the clients, with the customers, with the product owner, get to know the domain. Many people think that you have to, if you are doing this, you are doing domain-driven design. You don't have to go into all the details of the domain-driven design and be like feel constrained by it. But you have to know your domain. You have to know what the project is about, and just separate your classes, your methods into proper domains. Again, this should be self-explanatory, but again, this is a real-life project. This was actually not that short. This was about 150 lines, I think. Can anybody read this? Does anybody know what this does? Yeah, me neither. I didn't touch this code. This code was left as it is. Mark, I don't know if you're still working like that on production. Yeah, probably, yeah. And I don't think anybody wanted to touch this because it was impossible to figure out. So yeah, you won't save anything. Use intention revealing names, do not abbreviate, do not use some kind of shortcuts that only you know about. You will save what, a couple of characters. You won't save memory, you won't save time, you have autocomplete. It doesn't make sense, you will just be hated by everyone else. Also use one word per concept. If you are getting something from the database, for example, don't use fetch in one place, load in other place, retrieve in some other. Use one of those. I don't care which word you choose. It doesn't really matter. As long as that word explains what it does, just use it consistently throughout the code. Avoid disinformation as well. Again, this should be self-explanatory, but again, this is actual code. Why was it called model and its new product filter? Why the variable wasn't called product filter? It makes no sense. So yeah, don't write like this. Try to be consistent and try to provide information to your developers as you're coding. Use value objects. Value objects are great. They are immutable. They are testable. They can have a behavior. They can have named constructors, which really simplifies things. Do not use arrays to return stuff. For example, here we can see you have is free provider, blah, blah. Now, everyone in outer code, you will have to check if the array is in proper format. Does it have the key? Does the key exist? And stuff like that. Instead of that, just create value object that has a provider, has a price. It has named constructors. Named constructors, if you haven't used them, use them. They're awesome. I love named constructors. So now it's pretty easy to read. Now we have this much, much easier to read. We have return shipping cost from UPS, which has a price. It's simple, it's testable, it's easier to read, it lessens cognitive load, it's easier to refactor. You can add any other new implementation here. You can hide implementation if you don't want someone else to know about it. So yeah, just use this. Krell has had a good blog post about it. Since PHP 7, there's no good rules not to define a class. It's twice as memory efficient. It's self-documenting. It's autocomplete. You can have autocomplete. You can add behavior. You can hide behavior. You can do anything with it. Does anybody of you know about broken window theory in general? Yeah. So in general, it means we have an abandoned house, and it can stay like that for years. But the moment someone throws the first rock and breaks a window, in like, I don't know, 2 months, it will be scribbled with graffiti, there will be squatters inside, all the windows will be broken, and stuff like that. That applies to code as well. If you do, like I'm gonna just do one little hack, and then your colleague comes and they will do just one hack, and then a junior comes and see, oh, we're doing hacks now. You see where we're going. We're going to end up with a spaghetti monster that you will not be able to contain, you will not be able to understand. Always leave the code cleaner than found, and try to be really proper about this. Be rigorous when it comes to developing and when it comes to refactoring. Try to make the whole team understand what the goal is. Try to make the whole team work towards the same goal. And try to be vigilant enforcing the rules and the concepts you had in mind. But also, know when to give up. What does it mean? There are always processes, there are always pressure, there are always deadlines. So be aware that sometimes you just have to take a step back and let others do their job without trying to force your own opinion on them. It's not your opinion, it's something that you decided it has to be done, but it doesn't have to be done right away. So, create tasks for cleanup. Do not enforce that it has to be done right away. It can be done right later. And yeah, actually do cleanup. That's really quite important. Do not just stuff it into the backlog and hope for the best. So, as Eva said before today, do not hate legacy code, because you will all write legacy code. You are writing legacy code as we speak. Well, not as we speak, but yeah. Blame the process, do not blame the people, and just because it is broken code doesn't mean it just grew up out of itself. There was some circumstances that led to it. And all code eventually is legacy code. And if I have to leave you here with one thought, it's this. Don't write smart code. Write dumb code. Write simple code. Do not write complicated one-liners that nobody else will understand. I see sometimes this with juniors. They want to, you know, oh, look what I wrote. This is so great. It's one-liner and does everything. Yeah, but nobody can read it. If nobody can read it, nobody can work with it. Nobody can expand on it, and nobody can refactor it. So yeah, write dumb code. Thank you. Are there any questions? You will give out notebooks for those who have questions.
What do you think about traits?
About traits? Personally, I do not like traits because I feel they hide the implementation, they hide stuff from you, and it's kind of harder to debug and harder to deal with them. So that's my personal opinion. I don't have anything to support that claim, but I don't like using them.
About code styling, if you need to put some new rules, I don't know, for 4 spaces for an indent, for example, what is the best approach? Do you make a giant pull request to, clean all the indentation of your code, or file by file, when I do just a small fix in a file, then I apply a PHP fixer on this file only, and step by step I will have a cleaner project in all in maybe 1 year, I don't know. So.
Yeah, so how do we approach code styling in load code, right? Yeah, first thing is, first we enforce it on all the new code, and for the old code we do it if we mess with this file, we will fix it at that point. So we want to go through everything. We'll usually just go through, if we are already touching it, then we will fix it. It will always be in a separate commit. Yeah.
Hi. Do you know a nice way using knives and axes to tell people who love inheritance that composition is really better for them?
What? I didn't understand.
How to tell people who loves inheritance that composition is better? Because I have a problem with that. They just don't get it, and we're stuck with inheritance sometimes.
Well, if you have someone who did that and who does that on the project, you can make them try to refactor what they did. That's one pretty good approach. Try to show them examples. Yeah, try to find examples of that, maybe from some previous project you did, or maybe find something on the internet. Try to show them in person. Try to get them to understand how it complicates stuff. So that would be probably my approach.
Thanks.
You know what is matryoshka, and you know what is Lego. So would you rather play with Lego or matryoshka?
That's a good one. Thanks.
That would be my way of explaining.
Anyone else? Yeah?
You mentioned in your presentation the proxy idea to hide the new solution and the old solution behind the proxy. What do you think about using feature flags for that purpose?
Yes, but it's kind of a different implementation. It's kind of different usage. I believe that feature flags are more suited, for example, like I mentioned, when you want to have both code running in production and just what will be done. And really the branch by abstraction is just about routing it differently based not on feature flags, but on the actual flow of the program.
Okay, thank you.
Anyone else? Yeah? Back?
You've said that you love legacy code, and you showed us the code that doesn't look like proper legacy, like spaghetti with unexpected requires or all that crap. Any advice how to love that code?
Yeah. Yeah, I just try to get some of it. I mean, some of those examples of bad code, for example, bad naming and stuff like that, that was really what we were working on. I can't say you will love it. I mean, I had more hair when I started working with legacy. But there is a sense of accomplishment, a sense of fulfillment once you are done with it. It's like when you're cutting the grass, you have a field that has long grass, and you cut through it, and then you look back and you say, that looks good. That's kind of a fulfillment that I get from refactoring legacy code. Okay? Okay, is that it? Okay, thank you very much.